Welcome, everybody. That was really phenomenal to see. I am Brian Keating, a Chancellor's Professor of Physics at the University of California, San Diego. And it's a real treat and honor for me to be able to welcome everybody here in person and soon to be joined by our famous astronaut hero in space, Jessica Meir. So it's a great pleasure to have not only with us the distinguished scientists that we have, and Jessica herself, of course, but also the Fulton K-8 middle school, as well as the Memorial Preparatory School for scholars and athletes. So it's really fantastic. There's going to be Q&A from these middle school students, and there's also going to be some questions from online viewers at the, that we've solicited as well as from graduate students from the Scripps Institution of Oceanography. So it's going to be a fantastic program. My specialization is studying space, in particular studying the Big Bang, the origin of the universe, and studying the far distant reaches of our universe. So it's a great treat for me to be actually communicating for the first time, doing this sort of long distance phone call, and it's going to be a real treat for you as well, I'm sure. So in just a couple of minutes, we'll be connecting with Dr. Jessica Meir, who, as you saw, has an impressive resume that's taken her from here in La Jolla, where we are today, all the way into space and down to Antarctica and almost everywhere in between. Just a remarkable career. In Antarctica, you heard that she studied the physiology of emperor penguins, which are everybody's favorite bird, and there's many movies written, made about them. Happy Feet, in particular, one of my kids' favorite movies. And of course, I've been to Antarctica twice, and I'm just as fascinated and a little bit jealous of Jessica as well for all the trips she's gotten to take. She actually, we learned earlier today in the Q&A session with the middle school students alone about her passion and how it was ignited when she was a student herself in high school, and how she wrote in a diary that she hoped someday to explore outer space herself. So she's really proof that these dreams that you have can come true, especially for those of you, and many of you here today, are interested in careers that are in the so-called STEM field, science, technology, engineering, and mathematics. And of course, we're known for many things at UCSD, including those fields, and especially here at Scripps Institution of Oceanography. She made history in October. Everybody remembers when Jessica and her fellow astronaut, Christina, made a first all-female spacewalk in the history of space exploration. Just a phenomenal experience, and for us to be proud of. She joins a long list of women astronauts in particular have been associated with UC San Diego, Kate Rubin, Sally Ride, and Megan MacArthur. And of course, the first American woman in space, Catherine Sullivan, received an honor, spoke at a commencement here at Scripps Institution of Oceanography in the 1980s. That's another connection that UCSD and Scripps Institution of Oceanography in particular has with the exploration, not just of our planet, but of our solar system and indeed the universe itself. So when she's in space currently, she's traveling about 5 miles every second. She gets to witness sunrise and sunset 16 times a day, but I bet it never gets old for her. And she's traveling, many thousands of miles an hour. It only takes 90 minutes for her, if you work out the math, traveling 5 miles per second to cover the entire distance, the circumference of Earth from where she is in low Earth orbit. So we're going to get ready to connect to the space station and have a conversation with our wonderful alumna, Jessica Meir, Dr. Jessica Meir. I'd like to now welcome the director of Scripps Institution of Oceanography, Dr. Margaret Leinen, to say some words about the institution and about today's event. So thank you very much.
Thanks, Brian. And before we connect to Jessica, I just want to join Brian in welcoming all of you from Fulton and from Memorial Preparatory. We are really pleased to share this day with you. I hope you're as excited as I am and all of us at Scripps are. Science can really take you to some amazing places. And in the little film we saw of Jessica under the ice in Antarctica and slithering through narrow places into caves. Those are great examples, but look where she is now. She's going to be speaking to us from space. And we hope that you're as excited about science being able to take you these kinds of places as we are. So Jessica, welcome back to Scripps. Margaret Leinen here. As well as 150 middle school students from Fulton K-8 and Memorial Preparatory, and of course, a lot of your friends and supporters from here at Scripps and the UC San Diego community. And as director, I want to make sure you know how proud we are of everything that you've done with this extraordinary background in oceanography and being able to realize this dream of yours to go to space. And we know that you're doing a lot of science up there, and thank you so much for taking time out of a busy schedule to talk with us back here in San Diego.
Thank you so much, Brian and Margaret.
Thank you so much, Brian.
And hello to all of the Fulton and Memorial students and all of my colleagues and friends back at Scripps. It really means so much for me to be able to share my life up here with all of you. It really is one of the big objectives of my mission, is to share this experience with as many people as I can, because I am so incredibly fortunate to be up here. I don't want to take any time away from the great students that the questions have to ask, so I think we should just get right into those.
Great. Thank you, Jessica. And Brian is going to lead us in taking care of the questions. Brian.
Thank you, Margaret. Thank you so much, Jessica. It's such a treat to have you up there looking down on us and talking to us. So we have questions from students, and they're going to line up now. So if you submitted a question, please line up, and we have a procedure for you to get there. It's the most expensive phone call we've ever made at Scripps Institution of Oceanography. So let's take advantage of it. Let's be efficient. So first up, I believe, is Melody, and she is from Fulton K through 8. So Melody, please take it away.
Hi, my name is Melody Wheatley. I'm an 8th grader from Fulton K through 8, and my question is, who was your inspiration to become an astronaut?
Thank you, Melody. Actually, there is no one individual person that I can identify. I started saying that I wanted to be an astronaut when I was 5 years old, and I think I was always enthralled with exploration and nature in general. Probably it was my mother that inspired me with that. I think I also saw on news and on TV the space shuttle program. We had a very active space shuttle program at the time in the 80s when I was growing up, and something must have captivated my attention and my excitement with that, and really just planted that seed for me to want to explore the world around me and to explore even beyond that here in space.
Thank you.
My name is Andres Cardona, and were you afraid of the takeoff?
I wasn't afraid, actually, and I think one of the reasons why we don't really have that fear response, or at least I didn't, is because we receive so much incredible training at NASA. I've been training for my mission up here for essentially 6 years. So we have been over and over all of the different things that we'll be experiencing. In the last 2 years, I spent a lot of time in Russia training with the Russians and the Russian space program since we launched to space on the Soyuz rocket. We spent a lot of time in simulators preparing for every step and every phase of the mission. So it was really interesting. I had been through that so many times in a simulator, which looked exactly like the real thing, that sometimes during the actual liftoff, I had to remind myself that this was finally real. You get so immersed in what you're doing and so focused with all the steps and actions you have to take as an operator that sometimes you forget that it's not just the same as all the practice that you've been doing. There were a few not so subtle reminders, though, when the rocket started groaning and shifting a little bit, and then as the different stages of the rocket separated and we got higher and higher away from the Earth, you could actually see those things falling off of the rocket outside of the window. So once I started seeing those signs, I realized it was true, but it really wasn't any sort of fear. It was really just excitement and a little bit of disbelief and incredulity that my dream was actually finally coming true.
My name is Nicholas Cow, 8th grade, and my question is, why does this International Space Station need different kinds of scientists like biologists and geologists?
Well, I think there are two main reasons why we want to have scientists like biologists and geologists and all other types up here. First of all, it's the best way to have any efficient and high-functioning and successful team is to have a well-rounded team. You can imagine if you had 6 people up here that all had exactly the same background, they might not be that creative in problem solving. So if we have maybe one biologist, one physicist, one military pilot, one doctor, one electrical engineer, we're representing all different kinds of fields that can become vital to accomplishing the mission that we have, to dealing with the experiments that we're conducting up here, and really, most importantly, we are all critical thinkers and problem solvers, just like any good scientist, no matter what field you're in. And I think those are some of the most important attributes for our work up here.
Hi, my name is Ariana, and my question is, what kind of classes did you take in school that helped you become an astronaut?
Well, Brian mentioned the common theme in everything that we do up here, and that is the STEM field. So science, technology, engineering, and math. Now, the nice thing is there are a lot of different options within those fields. All of those fields could lead to a career like this one. To become an astronaut, you do have to have a degree in one of those areas, but the choices are really broad. For example, I'm a life scientist, a biologist, and a physiologist, as I think you already just saw. Up here with me on my crew, there's an electrical engineer, there's a military doctor, there's a military test pilot with a background in engineering, and then our 2 Russian cosmonauts up here as well with their engineering and military and backgrounds. So all of these different backgrounds are basic paths that you can use to get up here. So spending time in any of those science, technology, engineering, and math courses really helped us all get where we are today.
Hi, my name is Naomi Nisa from Fulton K8, and my question is, what type of research do you do on the space station, and do you do any experience outside the space station?
Well, it's really amazing how many different types of experiments we conduct up here. And as a scientist, it is so exciting because, as you can imagine, once you eliminate these gravity-driven effects that are always present no matter where you are on the Earth, you might unveil a whole variety of responses and results that we never even thought possible. So we do experiments ranging from physiology and medicine, how the spaceflight environment affects our human bodies. We do experiments about combustion. Even flames burn differently in space. Without gravity, without convection driving that motion, flames burn differently. So we study in a chamber, we study how different things burn in terms of flammability and safety responses, also in terms of fuel efficiency that might enhance fuel efficiency on Earth and also for future spacecraft. We do biotechnology experiments. I did a DNA sequencing experiment called Genes in Space up here. And we do fluids experiments. We do really, as I mentioned, any type of experiment. And it is really an amazing playground as a scientist to be up here. And outside the space station, I was fortunate enough to go outside of the space station 3 times now on spacewalks. And those are actually not for scientific experiments. Those are for repair jobs. We have hardware both inside and outside the space station that's critical to making sure that all the systems work up here to accomplish our mission. And one of the things that needed to be upgraded were our batteries. If you've seen a picture of the space station, you can see the immense, very impressive solar arrays. We harness all of the energy that we use up here. All of the power requirements come from the sun, from solar energy. But of course, since we have these multiple times when we are in sun and then in shade throughout the day, we also have to have some efficient batteries to keep that energy when we're not in direct sunlight. So we conducted a series of spacewalks to upgrade those batteries to better, more efficient batteries, lithium-ion batteries, just like you're using down on Earth as well. And that, I think, was one of the most amazing things that I've done while I'm up here, is venturing out of the hatch in a spacesuit and having really nothing between you and the Earth below except for the visor of your helmet. It really is an extraordinary experience.
My name is Brian Keating. I'm in 42nd grade at UC San Diego. And I have a question from Instagram follower, one of your millions of Instagram followers. And I remind folks you can follow Jessica on Instagram and Twitter at @AstroJessa_Jessica. This is actually a question from one of the Scripps Instagram followers, and her name is Alma Renero. And she would like to know, besides coming to UCSD, what's the best advice for young women who want to become astronauts?
There does seem to be a trend with female astronauts in UCSD. It's a great connection. But I think the most important thing to do is to make sure that you identify your passion and do what it is that you really care about. Once you've done that, you do need to work really hard to make those dreams come true. And it sounds a bit trite when I say it, but it really is true. I think this is proof that your dreams can come true. I've been saying I wanted to be an astronaut since I was 5 years old, and because I had identified that as my passion and also identified other aspects of science and exploration that led me down that road and pursued it with a lot of hard work and dedication and perseverance and then a lot of luck, all wrapped together to actually get me where I am today. And the point is really anybody can do it if that's what you set your mind out to. And just to follow up on that previous question, I think I misunderstood a little bit. There are other experiments outside the space station. There are other instruments like the alpha magnetic spectrometer that are measuring high energy radiation. So looking at things like understanding and unraveling more about the origins of the universe. And this is actually an instrument which we just finished repairing with a series of spacewalks. So it's all connected up here.
Great. Thank you. Next up, we have a question from Althea.
I'm in 8th grade, and my question is, what obstacles did you face in order to actually be able to be a scientist?
And sorry, could you repeat that one more time?
What obstacles did you face in order to actually be a scientist?
Okay, obstacles. Well, I think a lot of hard work, a lot of application processes, but just like anything in life, things that are worth it, things that give you a great reward, involve a lot of hard work, involve some of those obstacles, and involve failing along the way. For me, one of my big failures along the way was actually in applying for this job. It took me a few different times to apply before I was accepted. And 4 years before I started in 2013, I also interviewed for this job in 2009. I made it all the way to the final round of astronaut applicants, and the people at Scripps that are there with you today remember that well, because it was just at the time where I was finishing my PhD at Scripps. And things went well at the interview. I knew I'd given it my best shot, but only 9 people were selected, and I wasn't one of them. So that was a pretty big obstacle to overcome, because I had gone through everything, and I thought, well, you know, I'd failed at it. It didn't happen. It didn't work out that time. And so I could have given up then. But I didn't. I waited until the next time that I could apply, and when I applied again this time, even though I thought, well, it'll be worth applying just to see, but I'm sure it'll be the same result, and I'm going to go through all of this again, and psychologically and mentally it's probably going to be quite difficult. But if I don't apply, if I give up now, then I'll never know. And sure enough, this time it worked out, and this time brought me to where I am today. So I think that's just was a lesson learned for me. No matter how many obstacles stand in your way, you have to be ready to persevere and to keep on trying, even if you fail along the way.
Hello, my name is Joanna, and was your space training difficult to master? And if so, what part of your training was most complex to adapt to?
There are a lot of aspects of our training that are difficult, and some are, you know, it depends on the individual about which things are more difficult. We do flight training, we learn the Russian language, since everybody up here on the space station speaks both English and Russian. We learn all about the different types of systems on board the International Space Station, since we have to be the people not just living up here. We also, if the toilet breaks or a light bulb needs to be changed, we have to be able to fix that toilet and change the light bulb. We can't just call a plumber or an electrician. But I think the one thing that is most challenging for most people is learning how to use and operate the spacesuit. When you're in the spacesuit, you weigh over 400 pounds, and it's very cumbersome, it's pressurized, you're kind of out at these weird angles, so you have really minimal dexterity in these big pressurized gloves. And it's also very mentally challenging, because your task has to be so focused, and it's a lot of hard work. Physically, it's about the equivalent of running a marathon. So with that physical and mental challenge, it's certainly one of the more difficult things that we do, but I think it's the most rewarding thing that we do. And as I just described, being outside in a spacesuit was, I think, to me, the highlight of my mission thus far.
Hi, my name is Alexei Navarez, and my question is, what are some hardships that you have gone through that helped you get to where you are today?
Well, I think the biggest hardship was the one that I just mentioned about going through the application process and having failed at it, deciding that I wanted to put myself through that again. So just remembering that it is always worth it to take a risk, and that if you don't take that risk, then you probably won't end up with a reward in the end.
Next, we have a question from one of our graduate students, a fellow graduate student, and her name is Tashiana Osborne.
Hi, Dr. Meir. It's really nice to meet you virtually. My question is, what can we learn about Earth's changing climate by observing Earth from space and by observing other planets?
That is a great question, and that is something that is really important to me personally. I think one of the things that I'm sure Brian can tell you about as well, the more that we explore other planetary bodies and our solar system, the more we learn about our own Earth and how it formed, and in turn that can lead to how we might be able to better protect it. Some of the things that we can actually directly see from our own eyes here on the space station are very relevant to the changing climate. I actually took some pictures for our Crew Earth Observations project up here, monitoring some of the glaciers, and these were in particular the glaciers in Patagonia, so in Chile and Argentina, and we've been observing these and taking pictures of those from the space station for many years now, and monitoring that retreat of the glaciers that is occurring worldwide. It's just very visible with the naked eye, and it's a dramatic example of the changing climate, and really proves and shows me, and hopefully shows the world, that we do need to care. We do need to do something to make sure that we are protecting and taking care of our one planet Earth.
Okay, next we go back to our middle school scholars, and we have a question from Athena Molina from Fulton.
Hi, my name is Athena Molina, and my question is, was it difficult getting accustomed to space and trying to do normal things?
That is a great question, and it is something that we don't really think about until we get up here, because we've had so much training on all the very specialized tasks that we do, how to use the hardware that's up here, how to use the spacesuit, how to fix the toilet, just stuff like that I mentioned. But the one thing that you can't train for are those really simple life things. What do you do when you can't just put something down? You have to learn how to use all of the space around you. We have Velcro or pieces of tape all around so that you can put an object down and still know where it's going to be. When you eat, you have to realize that if you have a bag of nuts or candy, turning it upside down is not going to actually do anything and help you get that out. And these are all very, very simple things, which of course you know in your brain that it will operate that way. But because our entire, as a species, through the entire evolution of the human species, we've always had this effect of gravity. And for our very short lifespans as individuals, we've always had everything we've known has this effect of gravity, where down is towards my feet. And if I let go of something, it will fall. And really reinterpreting, having your brain relearn all of those things up here, just how to eliminate that factor, really takes some time, and it is very interesting. I think it really shows how the plasticity of the human brain and how it can adapt and change. Just the way that I navigated around and how my brain adapted to the new surroundings. Within a few weeks, it seemed to be using a totally different neural pathway in terms of spatial awareness, where instead of just having down be where my feet is, sometimes during the course of the day, I might need to go get something up here. So suddenly I'm up here on what would look like the ceiling, and my brain in the beginning would sort of do this flip, and suddenly I would think this was what I would think was down again, but really it was up from relative where I was before. But even after just a couple weeks of being up here, my brain had seemed to use a different way of interpreting that in order to spatially orient myself, and it is really interesting to see. As a physiologist, I would have loved to have some kind of EEG or MRI measurement of the human brain as it's adjusting to life up here in the first few weeks especially.
Hi, my name is Ashley Nava, and my question is, can you communicate with your family?
Yes, we can actually. And so similar to the way that I'm talking to you right now, we can talk to our ground teams in Houston using these communications pathways, but I can also just call my family on a cell phone. We use an IP phone, so it's similar to how Skype would work, and it's a program on our laptops where we can dial a phone. And then we also have weekly conferences with our family members. So we have a video chat, just like Skype or FaceTime, once a week with our family to help keep us in touch with everybody that's back on the ground.
Hi, my name is Gianna from Fulton K8, and my question is, before you got accepted as an astronaut, did you ever consider any other career?
Well, I certainly did. I had a whole nother career, and that is thanks to Scripps Institution of Oceanography and UC San Diego and all of the mentors and colleagues that I had during my time as a graduate student there. My time at Scripps was invaluable. It really taught me how to think as a critical thinker, how to form and conduct something efficiently using the scientific method, and most importantly, relevant to my job today, it taught me a lot about working with a team. And I was working as a comparative physiologist, so I was studying animals, in particular animals that live in extreme environments, and trying to understand how those animals can do the incredible things they can. I was particularly intrigued by animals that live and work at extraordinary depths, so diving animals like emperor penguins and elephant seals, and also high altitude animals, so birds that migrate over the tallest mountains on the planet. And to me, it was just fascinating to understand how these animals could live in these very oxygen deprived zones. So diving animals, penguins, seals, they are air-breathing, breath-hold divers just like you and me, but they can dive for 30 minutes for an emperor penguin or 2 hours for an elephant seal. And it was just very fascinating to me to try to think, how can they do it? What is it that's special and unique, and how have they adapted to enable that extraordinary behavior? So I was working as a scientist in various universities and academia, conducting research with animals in the wild, and it was a very fulfilling career. But when the opportunity came to have this childhood dream job, I couldn't pass this up.
I'm Kayla Knight in the 8th grade at Fulton K-8, and my question is, what is the best way to describe the feeling of zero gravity, and is there anything you compare it to on Earth?
There are some parallels on Earth, and one of those is an airplane affectionately known as the Vomit Comet. And it is an airplane that flies in a parabola-shaped pattern, and essentially the pilot shuts off the engine at the top of that parabola so that the plane and everything in it is in free fall back to the Earth, which is essentially exactly what we are doing up here on the space station in orbit. So that in the airplane, since you're not quite up high enough away from the Earth and the effects of gravity, you only generate about 35 seconds of weightlessness. But it does feel a lot like it does up here, just that it only lasts for those 30-second periods. Another thing that seems quite familiar, that is something that you can even do there in San Diego, is go out into the ocean or go into a swimming pool. And if you go underwater and make yourself neutrally buoyant, so imagine if you have some weight on you and you're midway suspended in a swimming pool so that you're not moving up and not moving down. That feels a little bit like it, but of course you still have gravity when you're underwater. But that's what we do to train for spacewalks. We have a big pool where we use the spacesuit in exactly that way because it does have a lot of similarities.
Well, unfortunately, Jessica, our time is rapidly coming to a close, but we want to thank you so much. Deepest gratitude to you for spending so much of your valuable time with us here in San Diego, here at Scripps Institution of Oceanography at UC San Diego. It's been a real joy and a treat, and we can't wait to go diving and surfing when you come back here to La Jolla. Thank you so much, Jessica.
Thank you, everybody. It was so wonderful to be able to spend just a little bit of time with you. I only wish we had more time, but please follow along with my adventure and everything that I'm posting and that's coming down from the NASA social media and other accounts. There are lots of resources online. Thank you and have a wonderful day.
Bye. Well, that was amazing. Before we break for the day, I want to extend a big thank you to the chaperones, to the parents, to the teachers. We hope you come back many, many times to UC San Diego. And maybe, just maybe, if we're lucky, we'll get you to come here to be students here, either as undergraduates or as one of our many wonderful graduate students. So when you exit, there are some exhibits that you can look at, put on by some of the students here at Scripps Institution of Oceanography. You can look through microscopes. You can examine and learn more about places that you heard about today, Antarctica and the oceans and all sorts of other things here. And it's been a great pleasure. Thank you to the Scripps staff for hosting us, Dr. Margaret Leinen for being such a gracious host. And hope you all enjoy the rest of your time. And please, please come back again. Visit us at Scripps and the Birch Aquarium. Thank you so much. Have a great day.